There is a place on Earth where no sunlight has ever reached, where the pressure could crush a car like a tin can, where the temperature hovers just above freezing. And darkness is not merely the absence of light, but a permanent, crushing reality. A reality that has existed since the birth of the oceans themselves. This is not another planet. This is not science fiction. This is the deep sea, and it covers more than 60% of our planet's surface. Right now, as you draw breath, there are creatures moving through that darkness, creatures so alien, so perfectly adapted to their impossible world, that when we first pulled them from the depths, scientists could barely believe they were real. Creatures with transparent heads, bodies that glow like living constellations, eyes the size of dinner plates, or no eyes at all, jaws that unhinge like nightmares, bodies that seem to defy every rule we thought governed life on Earth. We have better maps of Mars than we do of our own ocean floor. We have sent 12 people to the moon, but only 3 have descended to the deepest point in the sea. The deep ocean remains the largest unexplored frontier on our planet, a vast 3-dimensional wilderness, where mystery is not the exception, but the rule. This is the story of that world, of the creatures that haunt its depths, of scientists who risk everything to find them, and of what these impossible animals reveal about life itself, about evolution's darkest and most beautiful experiments, and about the limits of what we still dare to call impossible. Our descent begins where the light begins to fail. 200 meters down, the ocean's Twilight Zone stretches before us. Here, in this dim intermediate world, the last photons of sunlight wage a losing battle against the growing dark. The water takes on a deep, haunting blue, the color of oceans in dreams. This is the realm where day and night blur into something else entirely, where creatures live in permanent dusk, and it is here that we encounter our first mystery, the siphonophore. At first glance, it appears to be a single creature, a delicate spiral of bioluminescent beauty drifting through the water column like a living galaxy. But look closer. This is not one animal, it is a colony. Sometimes stretching 40, 50, even 120 feet in length, longer than a blue whale, making it one of the longest animals on Earth. Hundreds of individual organisms, called zooids, each specialized for a different task, some for hunting, some for digestion, some for reproduction. None can survive alone. Yet together they form something unprecedented, a superorganism that challenges our very definition of what it means to be an individual. Evolution in the deep sea does not merely modify, it reinvents. As we descend, the light continues to fade, and with it, color itself begins to disappear. Red is the first to go, absorbed by the water within the first 10 meters. Then orange, then yellow. By 200 meters, the world exists only in blues and grays, and in this monochromatic realm, an arms race has been fought for hundreds of millions of years. Enter the hatchetfish. No larger than your palm, this creature is a masterpiece of evolutionary engineering. Its body is compressed, blade thin, covered in scales that act like mirrors, but its most remarkable feature lies on its belly. A row of light-producing organs called photophores. These organs emit a gentle blue glow, precisely calibrated to match the faint light filtering down from above. It is camouflage by counterillumination. Any predator looking up from below sees not a silhouette, not a fish-shaped shadow, but nothing at all. The hatchetfish becomes invisible by becoming the same color as the sky. But evolution never rests, and neither do predators. The dragonfish hunts here, a creature that looks like it was designed by nightmares. Its body is black, so black that it absorbs 99.5% of all light that touches it, one of the darkest biological materials ever discovered. But its secret weapon is even more remarkable. While most bioluminescence in the deep sea glows blue or green, The dragonfish produces red light, a wavelength that no other creature in its world can see. It illuminates its prey with an invisible searchlight, a predator with night vision goggles in a world of the blind. We are only 300 meters down. The journey has barely begun. 1,000 meters. The pressure here is 100 times that of the surface. The temperature has dropped to just above freezing, and the last traces of sunlight, the last photons that managed to penetrate this far, have finally been extinguished. This is the Midnight Zone, the bathypelagic realm, a world of eternal night. Here, in darkness so complete that humans cannot even imagine it, more than 90% of all creatures produce their own light. Bioluminescence is not a curiosity in the deep sea. It is a way of life, a chemical reaction, luciferin combining with oxygen in the presence of the enzyme luciferase, producing light with almost no heat. Biology has spent hundreds of millions of years perfecting what our best engineers can only approximate. The anglerfish drifts through this darkness like a demon from the deepest circle of some underwater hell. Its body is grotesque, all mouth and stomach, covered in skin so loose it seems barely attached. From its head extends a modified spine, a fishing rod tipped with a glowing lure called an esca. Inside this lure, billions of bioluminescent bacteria live in symbiosis, producing light in exchange for food and shelter. The anglerfish waves its lure through the darkness, a false promise of food in a world where every meal might be your last. When prey approaches, jaws studded with teeth like glass needles snap shut with startling speed. But the anglerfish holds an even stranger secret, one of the most bizarre reproductive strategies in the animal kingdom. The creature we've been describing is the female. The male is tiny by comparison, sometimes less than 1% of her size. When he finds a female in the vastness of the deep, he bites into her flesh, releasing enzymes that dissolve the skin of his mouth and her body. Fusing their tissues together, his eyes degenerate, his organs fail. He becomes nothing more than a parasite, a permanent sperm donor, his body absorbed into hers until only his reproductive organs remain. Some females have been found with 6 or more males fused to their bodies. A living assembly of spare parts in a world where finding a mate in the darkness is nearly impossible. Evolution does what works, not what seems reasonable. Deeper still, we encounter the vampire squid, whose name conjures images of horror, but whose reality is far stranger than fiction. Despite its name, it is neither a vampire nor technically a squid, but something else entirely. A phylogenetic ghost, the last survivor of an ancient lineage. When threatened, it doesn't flee. It inverts its arms over its body like a cloak, revealing a webbed canopy studded with bioluminescent photophores. It becomes a pulsing, glowing orb, a defensive display designed to confuse predators in the dark. If this fails, it releases not ink, but a cloud of glowing mucus, each particle a tiny light that hangs in the water, creating a constellation of false targets while the squid vanishes into the black. 6,000 meters, 7,000, 8. We have descended past the Midnight Zone, past the abyssal plains where the ocean floor stretches flat and featureless for thousands of kilometers. We are dropping now into the Hadal Zone, named for Hades, the ancient Greek underworld. This is the realm of the ocean trenches, the deepest places on Earth. The pressure here exceeds 8 tons per square inch. Temperatures hover just above freezing. The darkness is absolute. By every measure that seems to matter, this world should be sterile, dead, impossible. And yet, life persists. The Hadal snailfish holds the current record for the deepest fish ever recorded, filmed at 8,336 meters in the Mariana Trench by an international team of researchers in 2017. It is small, translucent, almost ghostly. Its bones are soft and flexible, its cells filled with organic compounds called piezolites that stabilize proteins under crushing pressure. It has no swim bladder, an organ that would be compressed into uselessness at such depths. Instead, it moves through the water with gentle undulations, feeding on tiny crustaceans and scavenging whatever scarce organic matter drifts down from the world above. At these depths, the concept of a food chain becomes almost meaningless. Life exists on scraps, on detritus, on what scientists call marine snow, a constant gentle drift of organic particles falling from the surface. Dead plankton, fecal matter, mucus, the shed skin of fish. Occasionally, a larger feast, the body of a whale or a large fish. An event so rare and so valuable that it supports entire ecosystems for months or even years. In 1977, scientists made a discovery that changed everything we thought we knew about life on Earth. Exploring the Galapagos Rift in the deep submersible Alvin, researchers found hydrothermal vents, cracks in the ocean floor where superheated water, reaching temperatures of 400 degrees Celsius, poured out into the near-freezing ocean. And around these vents, where all conventional wisdom said nothing should survive, they found thriving ecosystems unlike anything seen before. Giant tube worms, reaching 3 meters in length, their bodies bright red with hemoglobin, anchored to the rocks. They have no mouth, no digestive system. Instead, their bodies house billions of chemosynthetic bacteria that convert toxic hydrogen sulfide into energy. The worms provide the bacteria with raw materials. The bacteria provide the worms with food. It is symbiosis at its most extreme, two forms of life so intertwined that neither can exist without the other. These ecosystems don't run on sunlight. They run on chemistry, on the heat and minerals belching from Earth's interior. They represent a fundamentally different tree of life, one that could, in theory, exist on any rocky planet with liquid water and geological activity. When astrobiologists design missions to search for life on Europa, on Enceladus, on the ice-covered moons of the outer solar system, they look to these vents. They look to this impossible life in Earth's deepest trenches, and they think, if life can thrive here, in conditions this extreme, where else might it hide? 10,908 meters below the surface of the Pacific Ocean lies Challenger Deep, the deepest point in the Mariana Trench, the deepest point on Earth. The pressure here is more than 1,000 times that at sea level, equivalent to having 50 jumbo jets stacked on top of your body. If you dropped Mount Everest into this trench, its peak would still be more than 2 kilometers underwater. This is as far from the sun as you can get while still remaining on our planet. Only 3 manned expeditions have ever reached this depth. In 1960, Jacques Piccard and Don Walsh descended in the bathyscaphe Trieste, spending 20 minutes on the bottom before ascending. In 2012, filmmaker James Cameron made a solo dive in the deep-sea Challenger, the first person to reach the bottom alone. In 2019, Victor Vescovo piloted the DSV limiting factor to the deepest point, making multiple dives and discovering new species. What they found challenges every assumption: plastic bags, candy wrappers, evidence of human pollution in the most remote place on Earth, but also life, amphipods, shrimp-like crustaceans, some larger than your hand, thriving in conditions that should pulverize any living thing. Sea cucumbers crawling across the sediment, bacterial mats covering the rocks. And fish, actual vertebrate fish, moving through water under pressures that should make life impossible. These creatures are not struggling, they are not barely surviving, they are adapted, they are thriving. Evolution has had billions of years to experiment, to find solutions to problems we're only beginning to understand. The proteins in these animals don't denature under pressure because their amino acid sequences have been fine-tuned across millions of generations. Their cell membranes remain flexible because they're enriched with specific fatty acids. Their bodies produce specialized compounds that we're only now beginning to study. Molecules that might revolutionize medicine, engineering, materials, science. We descend into the deep sea expecting to find the limits of life. Instead, we find that life has almost no limits at all. We have explored less than 5% of Earth's oceans. The deep sea, this vast three-dimensional wilderness that covers most of our planet, remains almost entirely unknown. We have named approximately 240,000 marine species. Scientists estimate there may be more than 2 million, perhaps 10 million, perhaps more. Every year, new expeditions return with creatures no one has ever seen. Animals that rewrite what we thought we knew about evolution, about adaptation, about the very nature of life itself. The creatures we've encountered on this journey, the siphonophores and hatchetfish, the anglerfish and vampire squid, the giant squid and Hadal snailfish, represent only the teeniest fraction of what exists in the depths. They are ambassadors from another world, one that exists not light years away, but kilometers down, separated from us not by the vastness of space, but by pressure and darkness and our own technological limitations. What they teach us is profound. They teach us that life is far more resilient, far more creative, far more persistent than we ever imagined. They teach us that extreme is relative, that what seems impossible from our perspective may be perfectly ordinary from another. They teach us that evolution is the greatest artist that has ever existed, sculpting beauty and terror in equal measure from the raw materials of chemistry and time. But perhaps most importantly, they teach us humility. We are a curious species. We build rockets to touch the stars. We split atoms. We sequence genomes. We believe ourselves to be the inheritors of this planet. The most successful form of life Earth has ever produced. And yet, there are creatures living in the deep sea, creatures whose ancestors were already ancient when the first tetrapods crawled onto land, creatures who have survived 5 mass extinctions and countless climate shifts, creatures who make their homes in environments so hostile we can barely visit them, even with our most advanced technology. The deep sea is not just an unexplored frontier, it is a reminder that we live on a planet we have not yet fully met, a reminder that mystery is not something humanity has conquered, but something that surrounds us still, deep and dark and patient, a reminder that the universe holds wonders we haven't yet imagined, and some of them are right here. Beneath the waves, we cross without a second thought. There is still magic in this world, still beauty in the darkness, still creatures moving through impossible depths, glowing softly in the endless night, waiting to be found. The question is not whether they exist. The question is, will we have the courage, the wisdom, and the humility to meet them? Thank you for joining us on this journey into the deep. If you enjoyed exploring this hidden world, we invite you to join us again for our next expedition. And if you'd like to support this channel, please consider subscribing and leaving a like. Your support helps us continue bringing these stories to the surface.